Hi everybody, welcome to another video in course Algebra, section 3.3, dividing polynomials, remainder, and factor theorems. First, we look at log division. Log division is where we just take a look at a simple example. We have 1234 divided by 56. So we have 56 going to 1234. So 56 go to 123. 2 times 56 times 2 be to 111. So 56 go to 123 2 times, and then 2 times that back give us 112, and then we subtract, and that is 1 and then 14. 56 again 1 to go 114 2 times, and that also 112, and we subtract, that will be 2. So 1234 divided by 56 is 22 times, and 2 here's the remainder. Right. In that case, the 56 is called the divisor, and 1234, that is the dividend. 22 is quotient, and 2 is the remainder. Right, and we can write like this as well. 1234 divided by 56 is equal to 22 times, and then there will be a 2 remains on the top of 56, so we can write like this as well. Right, now we divide polynomials. Now if f of x and d of x are polynomials with the d of x not equal to 0, because we don't want to divide by 0, degree of d of x is less than or equal to degree of f of x. So when we divide, the dividend is bigger than divisor in terms of degrees. And then there is a unique polynomial q of x, which is the quotient, and r of x, which is the remainder. And we write in this case f of x equal to d of x times q of x plus r of x. And once again, f of x is the dividend equal to divisor times quotient plus remainder. That is the division algorithm. Now if the remainder of x has a degree, the remainder has degree less than the divisor, but if the remainder equal to 0, if that is equal to 0, then f of x is factor as d of x times q of x. Right. Now let's look at how do we divide polynomials. Let's divide x squared plus 10x plus 20 divided by x plus 3. So we have x plus 3 go into x squared plus 10x plus 20. Well, now we only divide by the highest term. We cannot take more than one term divide. So here we only take x go into x squared, only the highest term. So x squared divided by x the highest term, x squared divided by x, is an x. So when we write x plus 3 go to x squared, x times. Right. And now we will take that x multiply to the divisor. Just like when we have a 2, we will multiply that with the divisor. So we have x times x plus 3. That gives us x squared plus 3x. And so we're going to write x squared plus 3x here. Now we subtract them. So when we subtract, we just change the sign of the second, the second polynomial, the second expression, positive to negative, and we just combine them. X squared minus x squared cancel out. 10x minus 3x, that is 7x. Then we can carry the 20. Now x squared, the x squared cancel out. We have x plus 3 and then 7x plus 20. Once again, we can only divide the highest. So we take the 7x divided by x is equal to 7 particular plus 7. And we multiply that back. Seven x plus 21 positive to negative, 7x cancel out. 20 minus 21 is minus 1. So we have it, quotient and remainder. If we want to confirm it, actually we need to write as the answer. So if x squared in this form, x squared plus 10x plus 20, that is the dividend, and then plus the divisor of x plus 3 times the divisor, times the quotient, and then minus 1. Right. Dividend equal to divisor times quotient plus remainder. If we want to confirm that, we just multiply it out. So that equal to x squared plus 7x plus 3x plus 21 minus 1. So x squared plus 10x plus 20. Right. So just like that. By the way, I also need to mention that we can also write in this form. So we can also write as dividend divisor equal to quotient plus remainder over divisor. Yeah, but this is more common than this. Right. Let's look at another example. 3x squared plus 2x go into 6x over 4 plus 5x cubed plus 3x minus 5. Right? So 3x squared plus 2x. Now go into the polynomial x 6x to the 4th Notice that we are missing the x squared, so we have to put some x squared there. 0x squared, 6x to the 4th plus 5x cubed. Have to add the 0x squared there, just the placeholder. So we should have all the degrees. 4, 3, 2, 1, and the constant, right? And then we just divide like we did earlier. 3x squared equal to 6x to the 4th. 6x to the 4th divided by 3x squared divided by the highest power terms only. That gives us 2x squared. And then we multiply back 2x squared times 3x squared plus 2x, right? That gives us 6x. 6x to the 4th, sorry. When we multiply, we add the exponent x squared times x squared, x to the 4th, and then plus 4x cubed. So 6x to the 4th plus 4 x cubed. Right? And then we subtract positive to negative to change the sign positive to negative. That might be a typo, but anyway. So 5x cubed, 4x cubed. That gives us x cubed. And we carry the rest. Right. This should be minus, but anyway. So now we just divide the highest term again. X cubed divided by 3x squared. That gives us 1 over 3x. Right? And we multiply this back. Here we have fraction, but still numbers. So 1 over 3x, 3x squared plus 2x. Right? So that gives us x cubed plus 2 over 3x squared. X cubed plus 2 over 3x squared. And we subtract or change the sign positive to negative, positive to negative. And then when we combine, that gives us negative 2 over 3 x squared plus 3x minus 5. Right? And then we just divide by the highest term. Negative 2 over 3 x squared divided by 3x squared. The x squared cancel out. We have negative 2 over 3 divided by 3 is multiplied by reciprocal 1/3. So negative 2 over 9. and multiply backward to the divisor. Three and 9 cancel out. So we have negative 2 over 3 x squared minus 4 over 9 x negative 2 over 3 x squared minus 4 over 9 x. So negative to positive, negative to positive. That cancel out, and that 3 and 4 over 9. Uh, 3 plus 4 over 9, 9 times 3, 27, 31. Right, so that's what we have. The quotient and remainder. Now remainder degree is less than the divisor. So that's what we have. But that's not the focus on this section. On this section, we focus on synthetic, what we call the synthetic division. Kind of difficult to describe what we do in here in terms of step. So it's easy to explain by some examples. So what we divide is always when we divide synthetic division, the divisor must be x minus 3. You can only in that form. So what we do is we draw a line. So it is synthetic division. The coefficient here, that's what we start with. 1, 4, negative 5, and 5. If there is missing a term, we have to write 0 for that term. So 1, 4, negative 5, and 5. Those are coefficients. Now, if we divide by an x minus c, on this case x minus 3, just write down what numbers that number is. So c is 3, and I'm going to put 3 like that. Right, now we can divide. So synthetic division, these are the steps that we do. First, we'll write down the number. And so we have 1. Every time we have a number on the last line, multiply to c, and then put it back on the next column. 3 times 1 is 3. Multiply, put it in the next column, and then add. 4 plus 3 is 7. And then 3, when we have a new number at the bottom, multiply by c, put in the next column and add. So just like that, 3 times 7, 21. That gives us 16. And 3 times 16 is 48. And that gives us 53. And then the last number we will isolate out. That is the remainder. And this is the quotient. But in terms of polynomial, the quotient is going to be, we have 3 terms, so x squared, x, and constant. Just like what we have here. So we're going to, what we have here for dividend. So we have 1 will be x squared plus 7x plus 16. So quotient, divisor, remainder, and dividend. So we'll write x cubed plus 4x squared minus 5x plus 5 equal to the divisor of x minus 3 times the quotient x squared plus 7x plus 16 and then plus remainder. Right. Now, simple enough. Once again, the step. Write down the number. So I'm trying to write down the step. So number 1. Write the first number. Write the first coefficient of the first number. Next, when we have a number at the bottom, multiply to C, put it in the next column and add. So next step is the newest number at the bottom is multiplied by C. So that's why we have to write what is C and then put in the next column. Multiply, put in the next column and add. Multiply, put in the next column and add. Multiply, put in the next column and then add. So pretty much those are the steps. And then we just keep repeat until we have the remainder. Right. Now let's look at this example. X squared plus 10x plus 20 divided by x plus 3. So x squared plus 10x plus 20. So that is 1x squared plus 20 plus 10x. Plus 20 and then remember the divisor is in the form of x minus c. So in this case x cancel x, negative c is 3, so c is equal to negative 3. Divisor must be in the form of x minus c. Right, then we write out the 1. Write out the first number. Multiply, put in the next column and then add. Multiply, put in the next column and then add until we have the remainder. And this is the quotient, two terms, so just 1x plus 7. Since we divide by x minus c, the divisor is x minus c, so the quotient is always 1 degree less than the dividend. Dividend degree 3, quotient degree 2. Dividend degree 2, quotient degree 1. It's always 1 less than the dividend. Right. And then so we say x squared plus 10x plus 20 equal to the divisor of x plus 3 times the quotient x plus 7 minus 1. And that's what we have if we do the long division. Right. Once again, write out the first number, multiply, put in the next column and add. Multiply, put in the next column and add. Right, now we divide this into x minus 2. The coefficient 1, 7, 11, and negative 3. Divisor of x minus 2 in the form x minus c, so c is equal to 2. Right, so wrap the first number, multiply, put in the next column, 2 times 1 is 2, and then add, multiply, put in the next column and add, multiply, put in the next column, that is in 58, and then add. The last number is the remainder. So the quotient in this case, x squared plus 9x plus 29. So we say x cubed plus 7x squared plus 11x minus 3 equal to the divisor x minus 2 times the quotient x squared plus 9x plus 29 plus 55. Right. So synthetic division is rather simple. Now we just focus on two theorems that go with it that help us to utilize the synthetic division fully. So if a polynomial f of x is divided by x minus c, so that's where the synthetic division comes into place, then the remainder equal to the values of function at c. Well, that's actually very nice. So think about this. I would just write out division algorithm. We have now, since the divisor, since the quotient always have the higher degree than this, the quotient, the remainder have the lower degree than the divisor. So I should say the remainder has degree less than the divisor. So the degree of x is less than x minus c. So this is just a constant, because divisor is x minus 1. Degree less than that must be constant. And now we evaluate at x equal to c. Just going to put in c into the function we have f. Evaluate at c. So f x equal to c. The remainder just a constant, so we don't need to write x to say that is the remainder, just a constant. Now, c times c is equal to 0. C minus c is equal to 0 times that still 0. So that's just 0. That's why we have the values of the function. It's just the remainder, right? So instead of evaluate the function, we can just find the remainder, right? So at first, let's just say use remainder factor theorem. Use the remainder theorem to evaluate f of 2. So notice here we have the equivalent of x minus c, and then the c inside the values of the function. So in this case, c is equal to 2. The number inside the value for x of the function. So we take that and go into this. Drop the first number, multiply, put in the next column and add, multiply, put in the next column and add, multiply, put in the next column and add. So the remainder is equal to 19, and in this case the remainder is also the values of the function. So in this case, when we put 2 into the function, it is equal to 19. So the remainder is equal to the values of the function. So let's check to see if it works. 2 is turned to x, and then we have this function. Right, because we have 19. Then we say, why don't we just use a calculator like that to evaluate it? Well, of course we can, but the remainder theorem allows us to do that easier. And we said, how is that easier? Now allow me to write down the actual calculation here. So this is a calculation note. If we write down x cubed, x times x times x, plus 4 times x minus 5 times x, and then plus 5. Of course, then we put 2 in place of the x. Now, why would I write like that? So let's say how many calculations do we need? 1, 2, 3, 4, 5, 6, 7, and 8. So there are total 8 operations. Right? And now we have 1. Drop out the 1, so there's not really an operation there. Multiply 1. Put in the next column 2. Add, that will be 3. Right? Multiply 4. Put in the next column 5. I'm sorry. Let's just drop down. There's no operation. Multiply is 1. Add, so that's 2. Multiply and then add 3. 4. Put in the next column. We don't really need to do that. There's no operation there. 2 times 4 multiply, 2 times 7, 5. Put in the next column, doesn't count. Add 6. So potentially we have less operation than we just do that. Right. Next we have this example. Find f of negative 4 for that. Well, what I do is I will change this to x to the 4th, just so we cover more scenarios when we using synthetic division. Right. Now for this one, f of negative 4, so c is equal to negative 4. Right, whatever the number inside the parentheses, when we substitute for x, that will be c. Right, now the coefficient, 3x to the 4th, there's no x cubed, so we have to put 0 for x cubed, and that's why I try to change that to x to the 4, so we cover that case where we have a missing term. 3 for x to the 4th, no x squared, 4 for x, no x cubed, 4x squared, negative 5x, and 2. And the negative 4 is c. Write out the first number, multiply, put in the next column and add, multiply, put in the next column and add, and multiply, that's negative 208, and add negative 213, and multiply, put in the next column, so that 852, and that 854. So the last number is the remainder. Not only that, it is the values of the function where we substitute c into x. Right, let's see if it works. Right, x to the 3x to the 4 plus 4x squared minus 5x plus 2. Yep. Right, so to evaluate the values of the function, we just use synthetic to evaluate the values of a polynomial function. We just use synthetic division by x minus whatever the values we for x we try to evaluate. So that's what we have. That is the first application. That remainder theorem will help because we always in this case divide by x minus c, so that's very convenient. So the remainder is equal to the values of the function when we substitute c into x. Next, we have the factor theorem. If r is equal to 0, then f of x is divided by x minus c, and then x minus c is the factor of f of x. Well, that's what we mentioned at the beginning of the section. If the remainder is equal to 0, then we just have the polynomial equal to divisor times quotient. So this is factor. And if x minus c is a factor, then r equal to 0, then f of x is divided by x minus c. Right, next. Factor 2x cubed minus 3x squared minus 11x plus 6. Even that 3 is a 0 of f of x. What does that mean? 3 is a 0 of f of x, meaning that when we substitute f of 3 is equal to 0. So that is the definition of a 0. So meaning that if we put 3 into the function, it will be equal to 0, right? Now, so in this case, c is equal to 3. If this polynomial divided by x minus c or x minus 3, the remainder would be 0. So let's try that. We have 3 2x cubed minus 3x squared minus 11x plus 6. Write out the first number, multiply, put in the next column and add, multiply, put in the next column and then add them, multiply, put in the next column and add. In this case, we do have 0 because we say 3 is a 0 of f of x, so that's why we should have 0 here as the remainder, because remainder is the values of the function, in this case 0, right? This one we want factor, right? So in that case, let's write out the dividend equal to the divisor. Since c equal to 3, the divisor is x minus c, which is x minus 3. The quotient will be this, 2x squared plus 3x minus 2 plus remainder of 0. Of course, we don't need to write that. So now we see that one is factored into this, right? The remaining part is just we just need to factor the 2x squared plus 3x minus 2, right? So to factor 2x squared plus 3x minus 2, multiply two numbers, multiply together equal the first times the last, and they should add up to the middle number. So to multiply to negative 4 and add to 3, so that will be 4 and negative 1. It's 4 and negative 1. 4 and negative 1. X minus 3. And then 2x squared plus 4x, we can factor out a 2x. And then we have an x plus 2 left. Factor out minus x plus 2. Here's the common factors. So we have x plus 2 and 2x minus 1. Right, so we factor that polynomial completely. Now, let's tie everything together. If it is a 0, if a number is 0, x minus that number is going to be a factor. And when we use interior division, remainder will be 0. So, remainder 0 will give us whatever c is, it's going to be a 0. And x minus c is a factor. So those are equivalent. I'm going to write here. So if x minus c is a 0, that's the first thing, will be equivalent to the next one. X minus c is a factor. If c is a 0, x minus c is a factor, and the remainder equal to 0. Of course, when we divide by, when dividing by x minus c. Right. So those three things are equivalent. X minus c is a 0. I'm sorry. X equal to c is a 0. X minus c is a factor, and remainder equal to 0. So that is a factor theorem, remainder theorem, all tied together. So x equal to c is a 0. x minus c is a factor and the remainder equal to 0 when dividing by x minus c. Those three things are equivalent. Right, next, solve this polynomial equation given that negative 3 over 2 is 0. Well, now if negative 3 over 2 is 0, that means c is equal to negative 3 half, or x minus negative 3 half is a factor. Because that x plus 3 halves. Right, but c is equal to negative 3 half. Now we divide it by x plus 3 halves. This is a polynomial that we divide. The dividend 12x cubed 16x squared minus 5 minus 3. Now when we use synthetic division, we would expect to get the remainder equal to 0. So the remainder should be equal to 0 because that is a 0 and that is a factor, right? Drop down to 12. 12 times negative 3 half, that negative 18. 12 and 2 cancel out. 6 times 3 is 18 with the minus. That gives us negative 2. Negative 2, 2 and 2 cancel out. Negative, negative. So that's just 3. So negative 2. And then we add. And then multiply again. Negative 2 and 2 cancel out. We just have 3. And indeed, we should have 0 as the remainder. So that check. Because that is a 0. So remainder should be 0. Right. And then that is 12x squared minus 2x minus 2. So that is the quotient. So we can have 12x cubed plus 16x squared minus 5x minus 3 equal to the divisor x minus negative 3 half or x plus 3 half. And then the quotient plus remainder, which of course we don't need. Right. Now that helps us a lot when we solve the equation. We need this to be equal to 0. Now get back to the polynomial equation. Now, this polynomial is factored into x plus 3 half 12x squared minus 2x minus 2 equal to 0. Right? Then we just say this equal to 0. Or that factor equal to 0. So for x equal to negative 3 half. Of course, we can try to factor here, but I just use quadratic formula. Negative 2 plus or minus b squared minus 4ac over 2a. So you have 2 plus or minus square root that 4 4 times 12 is 48 times 2 96 negative negative. Well, that actually turned out to be 100. So we have 100 is 10. So we have 2 plus or minus 10 over 24. Right? 2 plus 10 divided by 24. That is 12 over 24 is 1/2. And 2 minus 10 over 24, that negative 8 over 24 is negative 1/3. So we have x equal to negative 3/2, x equal to 1/2, and x equal to negative 1/3. Right. So let's check based on using the graph 12x cubed plus 16x squared minus 5x. Of course, I can use this as a power, but sometimes x cubed, but just type x 3 times will be faster. Right, let's zoom in. Right, so look like this: negative 3/2, negative 1/3, and then 1/2. Right. Now the question is, what if we don't have the negative 3/2? Because the key here is we know one of them is a 0, so we reduce the problem from a cubic polynomial into a quadratic. So that's why it's doable. What happens if we don't have the negative 3/2? Well, in the next section we will study about that, or we can just use a calculator and then we find the first solution. And then we say, even then, how do we know if it is 1/2? Well, we talk all about that in the next section. But in this section, we learn mostly the synthetic division, and an application to that is if x equal to a number, let's say c, if x equal to c is a 0, then x minus c is a factor, and the remainder will be equal to 0 when we divide by x minus c. So if this is a 0, then when we use synthetic division by x minus c, remainder is 0. So let's say put a check mark there, that to be expected. And then when we break down to quadratic equation, certainly we can just do factoring or any method. We should get the solution once we get to quadratic equation. Anyway, that's all I want to cover in this section. Thank you for watching, and see you in another video in course algebra.